Hello. Okay, let's get started. And today I'm going to start using SAS. And everything I talk about, uh, your job, so stop me anytime. I'm basically trying to show you that whatever I'm doing in SAS, I can do it in Excel, or at least you can manually doing it. Okay. And so the file, just go to SAS and the stuff I'm going to using are some simple example. Uh, in this example, A1, A2, they all relate to principal component. Okay, and here I would like you to just type proc print com in Google and see the SAS Help Center. There's a principal component uh, piece. Okay, in the principal component piece, they have a lot of explanations one by one. What's out statement, what's covariance statement, okay, omit intercept statement, and they have explanations for everything's one by one. My personal view, well, at least I confess, when I learned SAS, even 30 years ago, 40 years ago, at the time, the manual is about 120 bucks a set. I never really read a manual, even I bought a manual. And what is the best way to learn R, learn Python, learn MATLAB, learn Arena? A lot of time I would say is that play with it. And the other thing is that a lot of the time I play with it, I use Excel. So whatever I did Excel, I double check. I can get it from SAS. I can verify how it's done for a small scale. Then I understand the grammar and uh, the like the syntax. And then once I feel comfortable with it, I just experiment with it. And one thing's good about uh, you know a computer today is it's very forgiving. You got something wrong, uh, you just try another version. Actually, I would say that's the part that you guys need to worry sometimes is a lot of program, including SAS, is very forgiving. So you even you put in something wrong, if you don't double check, you still get the answer, and at the end, you're writing science fiction. And of course, I will argue today's AI ChatGPT is worse. The deep fake, the hallucinations, it's even worse than the old SAS. Is it just ignore? It's wrong. It's not verifiable. It's not based on fact. It just keep going until you find a science fiction you like. And so, uh, yeah, the scientific attitude is something you need to be careful in any programming. Okay, and so here are the part I would show you is I'll start from see here if I now let me skip the example. Look at overview. Uh, don't read it unless you really like to. I'll use this one. Get started. Get started. I got a crime of 100,000 population by states. Okay, and so if I copy this whole things, this whole code, see from here, it's using different colors, so you can tell it's the code. Okay, and once you have the code, okay, if you already have SAS or you want to, you can download SAS from school or you can download from uh, SAS website. It's free now. And then you go to editor, okay? And if you go to editor, you just do a control V. You got everything downloaded. Follow me? Now, first, the title. You can have more than one title. You can have title 2, title 1. Just add another title. Let's just use title 2. And then, comma, this is the first SaaS run. And then, quote, unquote. And SaaS is like MATLAB. You need a semicolon to get the whole things done. And here is something I like to do. Okay, usually at the very top, I'll say options. Means that when you come up with the output, usually I'll say no date. What's the other one? No page. No, I think it's no number, right? Yeah, here we go. And why I'm doing this, when you print the output, usually, especially I print it in PDF. And once I print it in PDF, there will be on top of every page, there is a page number and or the date. And if I'm using this, usually you know what you're going to end up doing is you capture the figure, the table, you dump it into your Word file for your report. And so, if you do that, sometimes you just don't want to have those things there. Okay, and this is useful, especially when I was in industry. You don't want to let a customer know that you got your last version, working version done 2 o'clock in the morning. You want to let them feel like you get this whole thing's done, weeks before. And so that's the reason you're doing that. Okay. If you don't want to have that, just a star, put a star that will comment that out. Okay. And that's one way to do the comment. The other way to do the comment is this. Okay. You just have a slash and star slash. That way you see a bunch of green. I usually say that when I see UNCC green, that means that I have some documentation here. Okay, so history, historical documentation. Okay, for double check. Okay, and sometimes when you do this, okay, this is the last fully functional copy. And because why? Sometimes you run and run, and then you have so many versions, and at the end, you just couldn't remember which version works. Okay, so you can do that. Okay, those comments never happen in the you do comment from time to time. Okay, after that, okay, see here is a star. You can show all the data, or you can compress the data. Okay, inside, okay, data, the name is crime. So we're going to show that state by state, Alabama, all the way to different state. And for you guys, you probably like to use data lines, but I started old days. I'm using punch cards, so I use cards. Okay, and then after that, doesn't matter when you start. You see a yellow block that gets started. Okay, here is the tricks you need to know. Is this? Okay, state name is alphabetical. So since it's alphabetical, you need to have a dollar sign behind to say, hey, I'm gonna have 15 alphabetical. So watch this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. See here? So this is the first 15 you got blocked for Z. And next things you can tell is after that, murder, rape, robbery, assault, burglary, larceny, auto theft. And then after that, you have tons of states. And for some of you, I do, okay? A lot of time I will monkey around this in Excel. So all you need to do is just I did a Control C over there and Control V over here. Oops, sorry. I need to do this. Copy. Let's see if I can. No, I'll do it that way. I'll do it the not so good way. You guys can pay special, but suppose I did this. See here? It's all in one column, right? And I don't know, you could download some data from your company using Unix or using different format. So Excel is our common, well, at least for me. Uh, this is my toy playground. So here I just go to where is the data text to column and using denominated, and then I will say next. Okay, I will use space and see that. So you finish and you have everything's done. So now remember, oh, we're in trouble because here we have some names are 2-digit. Okay, so I'll go back. Okay, and let me do this text to column, fixed length, next, and then, okay, this one looks okay. So now it got formatted the right way. And since you guys intuitively understand, we need to center around mean and find the standard deviation. So immediately I can do this, right? I can do bubble sort and do the ranking. Yeah, if I want to, yeah, I can just rank. Okay, I don't know. This is I think first one is, let's see, what's that for? I think it's what's the first crime? Yeah, murder. Okay. So you just rank state by state, all of them, and then that's 50 state. Okay. Lock that. And so you have the ranking of the crime. Last one is for H, right? Yep. Okay. And then, so I can just go down and Control V. So what I will call this, whatever the projects you do, first get the data, first you can read it, first you can monkey around in Excel and in SAS. Okay, so you can double check what will be the next things you do. Probably find the average, right? And then and wow, on average we have 7.44 murder. Let's check Carolina. Do you think we're above? We're above. Huh?
That makes sense.
Yeah. Okay. Yeah, and that's another thing. Okay, and that's beyond. Uh, well, I wouldn't say beyond, but statistics is for you to come up with a scientific evidence to back up your story. Okay, so if I, for example, uh, I'm gonna work for the city of Charlotte or work for the governor of Carolina, and then I want to say, oh, let's set up priority. And what would be the first thing I do? I'll say that, okay, were we rank above or below the average of we're on the right side or on the left side, and then prioritize those things we care about. Do we have enough resources to uh, figure out how to accommodate it? And sometimes I don't have one resource; is a combination of logics in order to do that. So, yeah, writing a report, if you have a nice story to tell at the very beginning, you attract your boss' attention, do it. Okay. And next, find a standard deviation, or let's say find a variance. Let's find standard deviation. Since we're gonna find a variance, covariance in the standard deviation of a set of data set. So you have these two terms, and then make it look nice. So I'll go here and said, okay, cut down my number. Okay. Here, I don't really need that, but I just do it for fun. Okay. Since there's 50 states roughly, so I got it. And well, double check here, pub quiz. 50 state average should be median value 25. How come I got a 25.4?
Because you rank them, so the maximum they span from 150. So
No, no, no. You rank them, so you have 1 to 50. So yeah, and okay. And then how come the standard deviations vary a little bit? Because you divide it by n minus 1.
oh,
That's uh, not important, but what I'm saying is you should kind of check. And so, of course, this value really not mean much. And then after that, what will you do? You can find a covariance structure of the whole things. So you can just say that, okay, I have a covariance. Okay, and if I do this, I'm going to have the sample. And then the reference is locked, so I got my B locked. And I do that. I should have, okay, the correlation coefficients, covariance structure by structure. And of course, you can immediately start looking at this is that how come I have so much variations, covariance in this? So what is E? And you start speculating. And the other things you can do is this, right? For any column, I can start saying that, okay, I'm going to use C as my frame of reference. And then you know what I'm really checking is these two are equal. That means what? I know my covariance structure is clear. And then of course you can do your correlation coefficient structure. And I'm not going to do it. But if you go back to SAS, okay, you can do this, okay? And this ODS graphics on is to make the graphic look nice. I heard people tell me that you don't need to write these two statements anymore, and but I keep it. This is just say that when you print picture, print those nice looking pictures so I can easily copy paste, use it in uh, uh, okay. In here, the ID is state by state, okay, and then it will do a so usually you can do ODS on, ODS off, okay. So this whole things so far. Uh, let's double check. Input state after state, and I'll tell you why it's return, because see they only have this many column, right? So you just hit a return to make it look nice. Okay, so the first 15 column for state name. After that, just uh, some numerical number. It will just read it until it's in. Okay, and one more things you could use, but maybe not in this case, is that sometimes at the very end, add an ampersand sign. When you do an ampersand sign, means that you're reading data not in a tabulated format. It's kind of just run on and out. So if I do an ampersand, I can make this long. Okay, so it will just basically said, oh, read a name 15, and then after that read something, read a name very long, and then do something. Okay, so for me, let me just do this. Okay, I will. Homework you don't need to turn in. Just you can do it this way if you turn the data into some strange looking arrangement. Okay, so this is kind of like just play with it. If you make it look strange, and see why this thing is green or strange looking color, because I don't have a semicolon. If I have a semicolon, or done. Okay, and so far so good. Uh, I don't care. Okay, my first language is Fortran 4, and you you don't know how they come up with the language. Just follow the format. Okay, and then do principal component. And right now, okay, I would say usually I'll do this before I do a principal component. Whatever program I'm doing, usually I will do a proc print statement. And what's the proc print statement going to give me? A, a tabulated format of everything I read it, so I can double check. Okay, and then sometimes, so if you want to do it in a clear way, suppose there are many data sets. Data equal to, I think it's called crime, right? Yeah. Okay. And then after, huh?
Is it capital C though? I don't know if
It's SAS is not that sensitive to that, but I prefer follow. So why? When you in the field, uh, well, this I'm not saying I'm doing it good enough, okay, but I think this is even my teaching philosophy. You play, let them watch, and then play together, like training bicycle. Let the kids pedal. You in the back holding it. After a while, you feel the kids doing the good jobs. You just let go and let them keep playing. And then so now they're on their own. And now since they feel so confident, so you're gonna kick the back tire or just challenge the balance a little bit, make sure everything is fine. So what I'm saying is that during this teaching demonstration process, show and tell and then play, uh, don't at the beginning, don't let them get frustrated. When I try to show my customer or my student something, I hope I can minimize the unnecessary entropy and focusing on the stuff they care about. Okay. And why I'm saying this, when you write your final report, if you're not doing something, don't put it in. Only put in the stuff you can explain and they can understand, or I can understand, then gradually build it up on that. Okay. And so uh, if there's no need to change from capital to small letter, don't do it. Okay, after this, now see I have one print to print that table. One print gonna print the principal component, and then I'm gonna plot, okay, the ellipse circle, the cloud, and then the component I have is no more than is log at 3. So technically speaking, how many dimensions I have? 1, 2, 3, 4. I have 7 dimensions. So 7 dimensions means what? If everything is independent, you know, nothing correlate to each other, I should have how many dimensions? I should have 7 dimensions. But now let's just say that things are increase or decrease. I'm writing science fiction here. Okay, so I would say that I consider if you're in a GDP per capita low area, sometimes crimes goes up. And what kind of crimes are very, very high? Well, stealing, right? But then if you have a lot of, you know, uh, abandoned houses, you start seeing larceny increase. And then, of course, what crime go hand in hand with other crimes? And what will be the way to evaluate this? Is one is uh, violence related. Okay, that's what psychosocial. Uh, where I'm angry and I don't know how to resolve my anger, so violence is one way. And then what will be the other things are uh, gonna be is nonviolent crime, but if there is a dimension showing that people just hungry, they're not happy about their life because they don't have resources. That's the other kind of crime. And then you can see that, okay, you know what is Gini index? Basically, top 5% or 1% of the population, how much income they hold versus the bottom 50%. So if one person's on the top equal to, 200, 300, Elon Musk equal to how many people, and then you can tell uh, if there are social injustice or no, not necessarily injustice. Just the winner takes all, and the loser got no way to catch up. And then you see a different kind of crime. So, can I write this kind of argument before I introduce the data set? That's my hypothesis, right? So, your company, your manufacturing line, there are errors, and there are errors inherited because the supply chain when it's coming in, you don't know what's going on. So a lot of time, uh, the first one, is wrong, and then just accumulate until it's too late. And so this is kind of like you can identify certain things from upstream, and then there are also another type of like construction. If you check the cement quality, usually at the beginning it's very good. Why? Because people just started, they will check. But at the end of the day, at the end of the projects, what will happen? People want to get it done so they can go home. Then the quality becomes bad. So you can tell there are start from accumulate from the beginning, or the the certain problem at the end. So that's causal oriented. And then there are certain things related to somebody at some facility, at some assembly line. They just uh, not follow the rule. So you can basically find a scapegoat or find someone to be responsible for. And so I don't care is about crime or about quality control. Uh, you can speculate, and then so at the beginning we're writing our science fiction this way. Okay, so far so good. How, plot, score, and for everything I said here, I'm declare irresponsible for the formal definition. It's your job. Go to SAS, look at the statement by statement, ID statement, frequency statement, statement by statement. This is a SAS manual. It's free. You read it, and you can PDF download the whole things. Okay, and this is the user guide. It's just 1 month old. I think it's good. Okay, and partial statement is you reading the partial correlation or partial covariance. Remember, cofactor. Take one out and read the others. Okay, and so yeah, this part definition. Uh, no, uh, since we're not giving you exam for memorization, it's a lot more important. You understand how to play with it and what you're gonna get. Uh, Definition, your job. Okay, let's run the first SAS. Okay, have you done SAS before? Does it look scary to you?
No, it reminds me of a lot of art studio, but you pretty much have a data frame.
Yeah, yeah. But I would tell you this, okay? Uh, R, in the old days, SAS is not free. At least it's still not free for a lot of industry. And SAS since been out for so long. And I work for an insurance company. I work for airlines. We use SAS. And I was still in industry when the Millennium Bug's coming out, and we're looking for people using SAS and COBOL in a old database to make sure we're not gonna have a major crash of the system. And R is very, very friendly, very, very convenient, and the best thing is free. So SAS is trying to compete with that market. But why SAS still got certain market share? I'll tell you that a lot of big company, the old dogs still at the top of the pyramid. They basically said, well, I said that to my lab technicians, the same things as that I don't care what R program you're going to run this, my old one. Let me see everything's look the same. Your principal component, your eigenvalue, eigenvector, everything look okay. Then you can, I have enough confidence, then I'll let you use R. Okay. And so far, I still think if you put I know how to run SAS and R in your resume, uh, still is a plus to put it in. Okay, especially in Carolina. SAS is from Cary, right? So that's the beauty of it. Okay, so let's run it. How to run these things? Okay. Oh, before you run, you can always do a save. Okay. And if I'm doing a save right now, I would say uh, yeah, I'll do it here. Crime. PC. Okay. And then, so this for save and printer for print. search using this. So see the little guy here? That is to say called submit or run. Okay. There are macro, you can run tons of stuff together, but that's beyond the scope uh, of this class. You just need to learn how to write a macro to control a bunch of subroutine. So you can have different combo. Okay. So run. Okay. It's done really quick, right? So see the first step, create the name. And usually I will check my data set, first number, last number, no, not here, 282, and then I'll check last number, 282. So far so good. And then usually I will do another one, check is to find a very, very large number somewhere, say here in Nevada, and then this is 4,000 something. Is this the biggest number? I don't know, but I will check this two number. And usually, if there's any reading error, you might get it from there. So Nevada, 2453 and 4212. I'll go back. Nevada, 2453, 4212. Okay. And did this happen to any students before? They got the whole report submitted for their capstone projects or for whatever, and then last minute the customer said, "Hey, this number doesn't looks right." You shift one digit left, and then whole thing's crashed. Okay, you have to start all over again. And so double check beginning and look at a couple number to double check. It's important. Okay, next. After you got a number read, 50 observations, 7 variable, their mean and their standard deviation. So one thing I can do is this, right? I can copy and go to my Excel and just okay, copy. This time I'm going to do a paste special. Okay. Let's see. Yeah, here we go. Oh, I got a wrong location. And looks okay, right? One things I usually, if I have say 15, 20 variable and I have batch by batch I'm looking at. So one things I can do is just subtract was my double checked, and then just everything's zero. That means my Excel and this looks okay. Agree? Next, okay, you can just do this and go back and said, oh, I'll have a covariance matrix or a correlation matrix. Oh, they're only using correlations. And so let me just play this for 1 second, okay? You can just do this, okay? At the resorts here, go to crime, go back to resorts here, and then just delete, okay? That means you clear the whole things. And over here, you can just go at the end here. I will do a COV. Means that I would like to have the covariance structure done. If I don't, it always only gives me the correlation coefficients versions. So if I do a COV, it will give me a covariance version. So I'm going to rerun this. Okay, and go back up. See here, before I don't have the covariance version. I only have the uh, one version. Okay, so if I'm using the covariance versions, okay, and it will give me this 14, the covariance matrix, and I think you know that this is symmetrical, so you can run this for covariance version, find the eigen, and you can run the correlation versions. So let me go back here, page special. Okay, double check 14, 20. See, here is a little bit different value. And so computationally, there's a bit difference when you calculate that. But you can do some things here and say how big is the difference. Okay, and I think this is related to here. I'm using well, you guys can double check. It's using different approach. You have the value differently. Okay, so let's go back here. Let's delete this whole things. Okay, and go back here. And I'm gonna start. And using the correlation versions to run the whole things. Okay, and so far so good. Yeah, covariance version versus correlation versions. What's the difference when you use covariance version, when you use correlation version?
For correlation, you're looking for the trend, how they trend together, whether they follow the same slope.
Okay, I give you partial credit. The most important thing is covariance is just the rectangle of the area. It's not divided by their scale. Because if you divide it by their scale, you have the range from 1 to -1. So you know that correlation versions already, like we're using z-score in your last homework. Once you use z-score, covariance and correlation is the same things. So covariance versions basically said that I will let you demonstrate this associations based on their natural scale. So you can run this twice, one covariance version and correlation versions. You know what? Maybe I should do that. And let me, okay. And then one correlation version, one covariance version. And it depends, okay? If you just want to write a simple report, you prefer a correlation version and covariance version, a scree plot, what is important, what is not important, what are the principal things causing this crime rate to increase or decrease, the compo look the same. That's good news. What you don't want is because there is for example, say some sort of larceny, very, very high. And for example, we know that global warming, so certain states are, uh, you know, got some insurance issues due to too many hazard of fire. So the scale just suddenly changed into a very, very large scale. Then for example, you can look here. Okay, just look at the original number here. See, insert. If I use you can tell there are certain value is tiny, or murder is tiny, but certain things, small petty crimes are very, very high. So you basically want to say that uh, if I want to say there's a common principal component to explain the compositions, I don't want my storyline change too much because of we're measuring one things in this scale, the other thing in another scale. Okay, and there's a way out on this if you really feel like, man, this is dominated by certain scale. Sometimes take log on certain variable. One log is not enough. Take two log. Then you can, basically convert the scale into a different dimensions. Uh, but right now, I'm just trying to show you that. So you have two storyline. Okay. Now I want to block my print. Okay. And then I want to have my, well, this one I'll want to block first. You can print the output crime components later. Okay. Crime, COMPONENTS. Okay. But now let's just focusing on this two. Okay. And okay. I know I'm getting wordy, but I want you to understand this is okay. I in ergonomics, for example. Okay. Ergonomics standard anthropometry. Okay. And I'm going to show you two different people. We know in general, okay, we want to, I don't care, design for people with wheelchair or without wheelchair. You want to make sure that it fit the person's height and weight and everything's. Design these things in a natural standard based on their height, their weight. So we have average people, average everything's, right? But sometimes if you're not careful, okay, standard. Let me see if I can standardized. Hmm. Let me see, proportional. I'm trying to show that
Like the ligament length ratios.
yeah, it's basically demonstrates that I design a chair or something, and based on the average length or average height, sometimes the average, you're gonna have a lot of people, the human figure, okay, become too tall or too short or too wide. So in other words, is that uh, you're having two different scale, say one for upper body, one for lower body, one for sitting, one for standing. And then when you try to combine everything into one big picture, you look at that human, you're going to see that they're either playing yoga or they're extremely slim or extremely short and stout. And why that happened, just you're using the right proportion. And using ergonomics, I think is one way to visualize this is that you want to come up with a storyline. to talk about how I should organize all the data set. But sometimes you're gonna find a trade-off between using covariance versus this. Okay, so now let's just run it. Okay, this time no printing, so we'll just go all the way. Oh, the old printing still there. So okay, so first you can look at a correlation coefficient matrix. Okay, 111. Okay, so let me just copy this table for you to think. Okay. Okay, here's my correlation matrix, and then look at my eigenvalue. Okay, and I'll put my eigen. Let me see which way is better way. Let me try it this way. Okay, I will have my eigenvalue and cumulative. Okay, and here, when I look at this correlation coefficient matrix, look at the value. Usually about this 0.6, 0.3, they're kind of in the same range. But this auto theft, okay, it's relatively smaller than everybody else. Okay, so you can tell some value are highly correlated, some value larceny and auto theft. It's about property damage. Burglary, kind of like somewhere in between. So burglary is somewhere in between. You see that? And next, you can do the eigenvalue plot. And this is basically said how many vector, like remember your jacket or the cloud. Okay, so if I plot this, okay, I can easily see the first component is important. And after that, the second component is important. 4.1 to 1.2, I'm going to keep. And then after this, I can either get rid of, stop right here, only keep 1 and 2, or I can keep 1, 2, 3, 4. Follow me? So elbow point 1, elbow point 2, and then here's my eigen dropped. And so how are you going to decide that? You can tell. They find the differences, okay? And the differences is basically, let me show you how I get it. The differences is always the upstairs, the big value minus the downstairs. So you get your 2.87 all the way to 0.35. See that? So differences is how, the slope, right? How quick it dropped from one to the other. And the second things you can tell is the proportion. The proportion, all you need to do just have the sum. Remember, all the eigenvalue is from the volume of this whole things. So 7 variable, 7 degrees of freedom, 7. And then you said that, okay, if the total is 7, so what is my first one going to occupy? 4 over 7 more than 3.5, more than half. So it should be more than 50% divided by 7. See where you got your 0.4a? Okay. The other thing is that I will tell you when I'm in the field, I like to use percentage because use percentage, people overcome people's fear. They just say, oh, 7 degrees, how much is there? Okay. And the other things you can think about is correlation coefficient is this, right? So if I just have 1, 1, 1, 1, 1, summarize the main diagonal of correlation is 7 degrees of freedom. So the total volume, I can use either 2 or 4 to represent that. And so here's the argument. If I have enough time to cover 2, I probably can cover 76% of the argument. But if I want to stop at 4, I can cover 90% of the argument. So what should I do? It depends. If I'm writing A plus projects, you want to show me something beyond. You can say that everybody knows this, but I see something, So, and of course, our causal structure, Bayesian networks, it's going to play a role and said that, see, here is that something beyond you need to talk about. Okay, so, okay, Cliff Note, Shakespeare, whole copy. Depends on which one you want to go. Okay, so how to get this accumulative, and of course, it's easy, right? It's always equal to first one as it is, second one equal to upstairs plus increment. So you will have your 100% done. Okay, and again, if I'm doing it, I like to use percentage. So far, so good. Next, we're getting into, okay, first one is where my jacket, my backpack, my cloud, where is the longest one? So you need to find the direction of the longest one. That's where your eigenvector coming in. I will give you a little bit of homework later. I'm using SAS, so you know how the eigenvalue, eigenvector in no more than 3 dimensions, where the value coming from. So SAS will give you a number, and I have the Excel version. If you want, I can give it to you. But what I really want is, do me a favor, do a 3x3 eigenvalue, eigenvector computation, so you understand what is the spectrum, the sum of square. Take the first scoop out, the second scoop out, where the eigen concept coming from. Okay, and it's good to be tortured that way at least one more time from your linear algebra, so you understand the nature. Okay, so next we're gonna do our eigenvector. Okay, so when you do the eigenvector, you have your eigenvector. Okay, and you know that all the eigenvector, they are perpendicular. So technically speaking, if I do a sum product, okay, of any 2 vector, right? Remember, jacket, long axis, my box, and my short one. Okay, should be very, very close to 0. Every eigenvector should be very, very close to 0. So in other words, you basically said there are a million different ways I can dissect this cloud. And this one, I'm using a box. When your jacket is long, I will use a long axis. When your jacket is Y, I'll use a Y axis. So any 2 value, should be all close to 0. You can monkey around with this. Okay, so principal component is just the box of the cloud, but this is based on the characteristics of the cloud. When you have a long one can dominate, I will give you a vector to demonstrate which direction to dominate. You have a second one only dominate 17%, I'll give you a 17% one. And then the third one and the fourth one. Okay, for student online, just think about this. Okay, this is principle of parsimony. This is the way how we see the world in a system engineering management approach. What does that mean? If I can find a linear combination to talk about something and said that over 58%, 58.8% of the variation can be explained by that vector, I will talk about that vector first. And then I'll say that, well, one is not enough. Let me have a second one and a third one. So this is greedy algorithm in disguise, right? This is my Chinese buffet in disguise. You go to Chinese buffet, start from the surf and turf. If they are steaks, they are lobster, the expensive stuff, eat those first. So if you pay 30, 40 bucks, you know that you're not wasting your space on something at the very, very end. Okay, so the scree plot I explained to you, when you run down, you have very, very high speed, and then the speed is not as high, and then sooner or later you're gonna fall because suddenly there's no more momentum, and you should stop. Okay, in this case, I definitely will stop at 4 because after 4, there's not much momentum. Principal component, first one, talking about what? You can tell. Here are 4 very, very strong stuff. Oh, I shouldn't use that one. I will use, I'll use this. Okay. So this 4, okay, robbery, assault, and burglary. Okay. And rape. Okay. And so, and then after that, larceny and murder and auto theft. So principal component, even I said that I would like to talk about this, I wouldn't consider, I can do a scree plot just based on principal component 1. What I'm trying to show you is this, okay? Do you really think that principal component 1 is dominated by 2 or 5 combinations, or everything's captured a little bit? So what this means, the state overall got a lot of crime or not a lot of crime. So this one is basically said that high crime rate state, low crime rate state, right? And so this is the first things. So this is the first vector, look like this. I hope you see where I'm going. Scree plot of the eigenvalue demonstrate priority. Stop, 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 let go. Principal for each one of them. So I will do the first 4. Suppose I'm going to do the first 4. So yeah, you can write this is my print 1. And then after that, this is my print 2. And print 2, you can tell, it's almost like if I ignore the robbery, murder, robbery, assault, the rape is tiny, versus burglary, larceny, and auto theft. So I'm writing my science fiction here. Would I consider this is confrontational crime. Okay, let me use different color. Confrontational crime versus no confrontation. I sneak into someone's house, I steal something, or you know. So basically, this is bad things happen, but you may not have the confrontational. In other words, is violent crime, rape is violent crime, murder is violent crime, robbery, assault, versus the other side. Okay, I'm writing my science fiction, but can you see where the science fiction coming from? Okay, and then of course the next one will be principal component 3 and principal component 4. Okay, and this time, okay, so number 3 is robbery. Number 4 is auto theft. Why those two are positive, I don't know. This is number 3. Oh, it's right here. So robbery and auto theft, very, very strong. And then the contrast on the other side is larceny. And of course, now it's your speculation. Is it possible that a robbery and auto theft go hand in hand? In the movie, you need a runaway car before you rob, right? Purely science fiction. But I want you guys to think about is your statistics should help you think about this. Oh, by the way, I did not review this before the class, so uh, no, this is purely I'm making up stuff. But okay, and then on this two is robbery against assault. Okay, no robbery and auto theft against this. So how likely you can go back and said that, oh, let me go separate my state, resort my state with high uh, you know high combinations. You can rank two of them, right? Those with high and high value on this two component and versus this two component, and see if we can see something uh, very different. And people actually argue a lot of time, culture-wise, right? The time zone really play a very, very different role. Uh, West Coast, Highway 66, all the way to the end, versus the you know the um, mountain area, or Chicago, and it's a bunch of farmland and ranch. Do you think their culture are very different? And I argue that the Western uh, trend, okay, during the wagon area, the Western movie, versus during the 1960s, during the big depressions, a lot of people run to the West. Uh, there are different kind of human nature, because there are certain people just said that I don't care how bad the drought, I'm not gonna move. So you will see people with different kind of combination. And then on the East Coast, you can easily tell. People say they talking about the Disky line, Carolina, Tar Heel, our personality of the state, do people consider, what our nickname, Tar Heel? What does it mean? We're stubborn on certain things. And so you look at the combinations of how this state different from the state above, Virginia up, versus the Georgia, and a lot of time you can see they are very very different. And how can you use psychosocial, economical, geological evidence to say that okay, crime economics really is geological uh, factor dominated. Uh, can you speculate that way? If you can find enough statistics to justify it, why not? Uh, just like people talk about. Uh, I know Triangle Park area in Carolina. They try hard. They want to be uh, the Silicon Valley of the East. But how come? I'll ask you to think about it. The Carolina economics got a lot of benefit from the Triangle Park area, but why we kind of like plateau to a certain range, all the bio technology or the quantum computing, we try so hard, but we did not get enough investment. Like the weather-wise, I think our weather is better than Silicon Valley. But how come we cannot attract uh, people? And when you say you want to write a proposal for a startup company, okay, uh, do you think those evaluations are important? But when you write it, you would like to have some principal component to back it up. So uh, I hope you see the game I play and why this is important. Okay, so now let's do it in a different way. Yeah, this is the principal component 1, 2, 3, 4. Okay, and the accumulative. You can draw this yourself easily. Okay, next, here is the component. Okay, you are talking about component 1 and component 2. Okay, people look at here. Okay, component 1, component 2. Do you see some quadrant obvious anyway? Maybe. Uh,
South Dakota, West Virginia, Kentucky,
yeah.
lower part of component one, but higher than two.
Okay. You can play with it, but I will tell you this. Okay. Uh, when my kids young, we drove a road trip and look at the cloud long enough and hard enough, my kids will see teddy bear. And then you're in the bathroom, and get bored. And look at the smudge on the water. Sooner or later you'll see your girlfriend's face. And why? Our psychology fool ourselves. Okay, but see here, and then component 2 against component 1 against component 3. Did you see something? And usually, what we want is to basically divide and conquer, and said that, oh, here are the zone 1, here are the zone 2. Something should be obvious, okay? And you want to say, oh, politically incorrect. You can start saying that, okay, this is a Republican state, this is a red state, this is a blue state. And does politics play a role in how things grow or shrink? Uh, I'll say that sometimes uh, you you talk to a congressman, you talk to people, they're looking at this all the time. And I can also tell you that there are a PR firm, consulting firm, they are using this kind of statistics to tell people, say A, B, C, but don't say E, F, G in front of certain people. How they figure that out? The first step is principal component. Okay, and now let's play with component 2. And this time I already checked covariance structure. And then once I have the covariance structure, oh, I made a mistake here. Here I should use the data. Yeah, let me redo this. You see what happened is I have the principal component from the correlation structure. It got buried into the data and start run because I have the output from prime output. Let me just do this using correlations because right now I don't want to have any combination. I just want to run one at a time. Okay. So if I do this, let me redo this. Yeah. Here we go. Run. Okay. So first thing first, okay, double check the number of mean standard deviation correct, and look at the this. You'll see symmetrical, and so I'll do it over here. Basically, go back and okay, auto theft. Oh, wrong location. Things you want to check is usually symmetrical, probably it's correct. And then there's a variance structure. And then next things, you can have the variance structure, build your eigenvalue and eigenvector. And when you build the eigenvalue and eigenvector, okay, it's very easy to see that the proportion, what happened? Just one component take 86%. And you probably will ask, how does this happen? And then, so in other words, you don't need a second component, just one component is good enough. So you should look at the eigenvector, okay? And look at eigenvector. It's dominated by what? Larceny and burglary. The rest, because the murder rate, the rape, is very, very small, so they got ignored. So this whole thing's just based on this, okay? And I can copy and paste. What do you think? Should I use correlation or using covariance to evaluate the whole thing? Covariance is no good because covariance is dominated by this. So in other words, I'm very quickly ignore all the other value because why? Because the code this values, look at it, it's so big, over 1,000. Then so the scale of this trump all the other stuff, and so the story is shrink too quick. So look at this, one, and then you really don't have much left. Okay, so this tell you principal component. Okay, at least in this case, I shouldn't use the covariance structure. I should use the correlation coefficient structure. Make sense? Okay. Okay. Now, You need to go early.
preferably. We've done an hour and 15.
Already done an hour 15. Then okay.
No, it's an hour 15 because you started.
Okay. Yeah.
It's technically hour 20.
Okay. So homework you don't need to turn in is go to SAS catalog in the stuff I show you, and there are a bunch of example, e.g. A1 to 8. Just run it, and it's showing how to calculate eigenvalue, eigenvector, and see if you can do it manually. Okay. Okay. And I'm gonna call it a day.